Hey guys, Mr. B here again, bringing you part 2 of the completing the square video. In the last video I talked a little bit about how we use completing the square to solve quadratic equations. Today we're going to talk a little bit about changing forms of quadratic functions. So if we have something like this, and my students know this as general form, or sorry, standard form. I know this as general form. That's what I learned it was called, but it doesn't really matter what you call it. Ax squared plus bx plus c. And we want to change it to what my students call vertex form. So y is equal to a x minus p squared plus q. So where p and q are your vertex, so your vertex is p comma q. So if we want to do that, we have to complete the square. Well, that's one of the ways we can do it, completing the square. So in the last video I talked a little bit about the formula that we use, and the formula that I use is c is equal to b over 2 all squared. So this is something that you really want to know, and it's useful for this stuff, among other things. And that's what we're going to use in order to complete the square. So let's do a couple of examples and then see what happens. Alright, so this is a typical example. We're asked to change it to vertex form or whatever your teacher calls it. So if you haven't watched the other video, it might be worthwhile to watch. But you know, it's really much the same process. So my first step always is to group up my x squared and my x term. So I'm going to put brackets around x squared plus 10x plus 5. So my goal is with this guy is I want to turn it into a perfect square trinomial. So all a perfect square trinomial is a trinomial that has the same factor. So like x plus 1 times x plus 1, or x minus 2 times x minus 2. It has the same binomial factor. It's a double root. If you graphed it, the vertex would be on the x-axis. So in order to do that, we need to use our formula. We need to find, all this formula does is it finds the value of c that makes a particular polynomial or a particular trinomial a perfect square trinomial. So my b value in this case is 10, and all I'm going to do, well, I'll rewrite the next step first before I find actually what it is. So it goes x squared plus 10x plus something, that's the number, that's the c value, plus 5. And since I'm adding something to it, it's going to be positive because we have to square it. Since I'm adding something here, I'm going to subtract it off outside here. So I'm going to subtract off that number, whatever it happens to be. So the number is 10 divided by 2 squared. Well, 10 divided by 2 is 5. 5 squared, and then becomes 25. So this guy's 25, so I add 25. So in order to keep it the same function, you know, I've got to subtract it out here. So I end up with y is equal to, I know I can factor this right now, but I'll leave it for 1 second. I'm just going to rewrite 10x, just so I don't not doing too many things in one step. I'm just going to do this math on this guy right here, so minus 20. So what I want to do now is I want to factor this perfect square trinomial right here. And the thing about it is it's always going to be the same factor that worked, the same number. So what adds to give me 10 and multiplies to give me 25? Well, 5 plus 5 gives me 10, and 5 times 5 gives me 25. Now the beauty about this is you don't even really need to think about it, because if you look over here, the number that works is always inside our little calculation here of c. So it's always after you divide by 2. You divide the b value by 2, you got your number. So I end up with y is equal to x plus 5 times x plus 5. So that's my factored form, minus 20. And then I go one step further, is I just basically rewrite this guy. Since it's x plus 5 times x plus 5, I can rewrite it as x plus 5 all squared. So there it is. My vertex form. so to say. Y is equal to x plus 5 squared minus 20. And if you want to know the vertex from this, well, the vertex is actually negative 5 and negative 20. You always got to make sure you take the opposite value, because if you look over to the form here, I have a negative p, so in order for that to change to a positive, it'd have to be a negative number in the p place. So this would be negative 5. Turns it to the opposite. So that's my p value and my q value. So that's my vertex. Alrighty, so let's give a slightly harder example. So this one's slightly harder because it has a negative and it has something in front of the x squared term. So again, my first step, group it up. So y is equal to negative 3x squared minus 12x. So I group up the x squared term and the x term, and plus 10. So the next thing I want to do is I want to factor out, no matter if it divides evenly, if it doesn't, take out what's in front of the x squared term. So negative 3, so I'm going to just take out that common factor, so I'm left with x squared. I could take out an x as well. I don't want to do that. I just want to take out the number. Take the negative 3, so negative 3 is out. And then this becomes positive 4x. At this step, you might want to just do a quick check, multiply back through, make sure you get what's in the original one. I think we do. Yeah, we're good to go. And then you make sure we got the plus 10. Alright, so this guy, we write in our blanks now. So I got negative 3 x squared plus 4x plus blank plus 10. And then plus blank. Alright, so let's see what we got. So we got c is equal to b over 2 squared. So remember, we do what? This b, not this original negative 12. We do the positive 4. So we do 4 over 2 squared. So that's going to be 2 squared, or 4. So then we're plus 4 here. Now this is the tricky part of when you have a number outside, especially with the negative. We're not actually adding 4 to this equation. We're actually adding negative 3 times 4. Because there's a negative 3 outside the brackets here, it's essentially, if you think about distribution, we'd multiply that everything in here by negative 3. So it's not like we're adding 4, we're adding negative 12. So if we want to counteract that negative 12 in our equation, we have to cancel it out with a positive 12. So it's a negative 12 over here, so it has to be positive 12 right here. So that's the tricky part. If you're on a test and you think something's not working out for you, and is one of these examples, you might want to just think back, did I do that? So alright, so now we're at the same position. So what I have here is a perfect square trinomial. This guy right here is my PST, and I'll just add those together. That's going to be 22. So I have negative 3, and then what adds to give me 4 and multiplies to give me 4. So the numbers over here, it's 2. 2 plus 2 is 4. 2 times 2 is 4. So I don't even need to write it out this time. I'll just write x plus 2 all squared, and then plus 22. So there it is. There's my transformed form, so to say, my vertex form. And it's simple as that, guys. So hopefully this helps you. See you guys in class, and if you got any questions, feel free to comment. Please subscribe. Thank you.